Soon after the work done by the Calais on the tree enumeration, William Hamilton discovered one of the game that correspond to the graph theory. In that game there were 20 vertices and each vertex correspond to the one of the famous cities. So there were 20 vertices and they were corresponding the 20 famous cities. The goal of the game was to visit each of the city exactly once before finishing the game, and that should end up to the city from the tour was started. So Hamilton sold that game to the London game dealer, but the fate of the game was that it was a failure and it do not leads to the success. So despite the commercial failure of the great idea, the more general problem of finding Hamilton cycles is an arbitrary graph is of critical importance to many scientific and engineering disciplines. The problem of finding Hamilton cycles look decisively simple. As we can see in this diagram, this was the sketch of the game and it represents the graph theory in which there were 20 vertices, number 1, 2, 3 and so on. And it looks very simple that if we started from 1, we can visit each of the vertices as it's represented by the cities once, but it is not so easy. So this game looks like very easy, but it is actually looks decisively simple and somehow similar to the Eulerian cycle problem. However, it turns out to be NP complete, while the Eulerian cycle problem can be solved in linear time. So as I have told you, it is a NP complete. So NP means the non-deterministic polynomial time. So it means that the problem can be solved in polynomial time using the non-deterministic Turing machine, like a regular Turing machine, but also including a non-deterministic choice function. So basically a solution has to be testable in poly time. If that is the case, and a known NP problem can be solved using a given problem with modified input, then we can say NP problem can be reduced to a given problem, then the problem is called as NP complete. So here we can see this Hamiltonian cycle problem, as we have seen as a game invented by the Hamilton. So the problem statement is we have to find a cycle in a graph that visits every vertex exactly once. It means that if there are 20 cities or vertices, then we have to visit the vertex only once. So the input of is that we have a graph G, as we have seen earlier, and we will get the output, that is will be the cycle in G, that it represents how which city is to be visited first, and it will represent in the form of a cycle that visits every vertex exactly once. As such, a cycle exits. So it will show the path within the graph, and that path will be in the form of a cycle.